Hello, my name is TyraCunningham. Thank you for joining me today. This presentation is for my capstone project for GIST 909. The title of this presentation is The Integration of Geographic Information Systems, Technology and Flood Analysis for Geological and Social Economic Hazards on the Navajo Nation. Before I begin presenting the details of my project, here is the land acknowledgement statement. Since my areas of study are within the state of Arizona, we respectfully acknowledge the University of Arizona is on the territories of indigenous peoples. Today, Arizona is home to 22 federally recognized tribes, with Tucson being the home of the Ororom and Yakwa. Committed to diversity and inclusion, the university strives to build sustainable relationships with sovereign Native nations and indigenous communities through education offerings, partnerships, and community service. Moving on, here's an overview of my presentation. These are the main topics that I will be going over, which is the goals and objectives, introduction, which includes the study area, methods and data, which include the dam, land cover, land use, hydrology, multi-criteria analysis, weighted overlay analysis, and then the results and discussion include the multi-criteria analysis, weighted overlay analysis, and then the flood risk maps, and then the conclusion. To start off, here are the goals and objectives of my project. The goal of this project is to analyze and evaluate flooding events near Marble Canyon and the city of Winslow for the years 2010 and 2020. And the objectives are to identify and determine areas where flooding occurs, determine the change in land cover from 2010 to 2020, to determine the populations affected by the flooding, to determine if there are areas that receive more or less flooding, and to determine if floods recur in specific areas. The area of study will be the Navajo Nation region in the state of Arizona. The estimated population of the Navajo Nation is 180,462, according to the 2020 Census Bureau. It has become the largest tribe in the United States. Majority of the people who live on the reservation are Navajo, leaving about less than 10% of the population to be a different race. The Navajo Nation covers 17,544,500 acres of land, occupying areas in northwest New Mexico, northeast Arizona, and southeast Utah. The climate of the Navajo Nation is mainly arid, resulting in a continuous drought. The data used in this project to analyze and assess potential flood areas on the Navajo Nation were obtained from United States Geological Survey, or USGS, AZ Geodata Hub, ArcGIS Online, ArcGIS Portal, Esri, ArcGIS.com, and the Center of Hydrometeorology and Remote Sensing, or CHRS Data Portal. The data captured for the dam analysis was obtained from the USGS, as I mentioned before. This data is the elevation data that was used for flood susceptibility analysis of Marble Canyon and Winslow, Arizona. The maps to the right show the dam data for each study area. Vector data, which included lines, polygons, and points, were obtained from AZ Geodata Hub, ArcGIS Online, and ArcGIS Pro Portal. The land cover data and the land use data were obtained from Esri's website, arcgis.com. This included aerial images of these two locations. Rainfall data was collected from the Center of Hydrometeorology and Remote Sensing data portal website. This project looks at the data from 2010 and 2020 for the area around Marble Canyon and Winslow. To achieve the goals of this project, an analysis of imagery and raster data was performed. The use of spatial data and remote sensing techniques are used to assess the susceptibility of floods using ArcGIS Pro. To understand the effects of floods, it is important to understand what factors are influencing the phenomenon. Slope hydrology, rainfall, and land cover are factors that are considered in this analysis. The following processes were performed to create derivative maps of the study area. Once the data for Marble Canyon and the area near Winslow was obtained, further analysis was conducted to delineate the hydrology network from the DEM by using different tools in the geoprocessing toolbox in ArcGIS Pro. The flow direction tool created a raster of flow direction from each cell or pixel to its downslope neighbor. The flow accumulation tool created a raster of accumulated flow or the sum of all flows from upstream of each cell. The stream order tool is used to identify and classify types of streams based on the number of tributaries in the area of study. And the stream to feature was used to vectorize the raster layer of the stream order representing a linear network. So these are the results for each of the methods used. This is the result from Marble Canyon. The data is used in the reclassify tool from the geoprocessing toolbox to classify the raster into five specific values, which were water, forest, developed area, bare ground, and scrub shrub. This is the result for Marble Canyon. And this is for the year 2017 land cover, and this is for the 2020 land cover. From 2017 to 2020, the water features near Marble Canyon decreased by 19.2 square kilometers. The forest decreases by 0.87 square kilometers. The developed areas increased by 1.12 square kilometers, and the bare ground decreased by 398.32 square kilometers. And then finally, the shrub increased by 417.21 square kilometers. This area is very rural with little to no population density. The developed area is seen around the city of Page, located northeast of Marble Canyon. There is little to no population in the Marble Canyon area. The closest city is Page, Arizona, which is less than 10 miles northeast of the area. This area is part of the Grand Canyon National Park. This means that this area is only visited by people and there are no developments beside a couple nearby towns. And this is the result for the land cover land use for the 2017, for the year 2017 near Winslow, Arizona. And then this is a result for 2020. The area around the city of Winslow, which is southwest of the Navajo Nation, is also classified as scrub and shrub with bare ground. The area near the city of Winslow, the water features increased by 0.53 square kilometers. The forest increased by 2.19 square kilometers. The developed area increased by 5.4 square kilometers. The bare ground decreased by 558.33 square kilometers, and the scrub shrub increased by 574.27 square kilometers. This area has a larger population density than Marble Canyon. There are also some forests and water features around the city of Winslow. Winslow, Arizona is a city located just on the border of the Navajo Nation in the southeast region of Arizona. The city is populated by 9,655 people, where 23.5% of that population is Native American. Here is the multi-criteria analysis method for Marble Canyon. To understand flood risk areas for the area of interest in this project, critical factors influencing the floods must be identified and analyzed. These factors include the Euclidean distance of the water network, the slope, the land cover, and the rainfall data. For the area near Marble Canyon and the city of Winslow, each factor was reclassified and displayed as a raster layer, and each raster had to have the same spatial resolution, cell size, and scale of classes. These layers are then combined to create a new layer, resulting in the weighted overlay. So these are the results for the area near Marble Canyon. This is the reclassified map of the Euclidean distance, the slope, the land cover for 2017, 2020, and then below is the result for the rainfall data for 2010 and 2020. Here are the results for the area around Winslow. Here's the result for the reclassification of the Euclidean distance, the slope, the land cover for 2010, and then 2020, and then 2010 and 2020 for the rainfall data. The Euclidean distance is calculated for each cell to the closest source. The slope identifies the steepness of each cell of the raster. The land cover is classified into 5 classes, which are water, forest, developed area, bare ground, and scrub shrub. The results of the weighted overlay analysis show the level of flood risk in the areas of interest. Each area of study shows the severity of flood risk. Each flood risk area has an allocated value from very low, low, medium, high, and very high flood risk. This shows what areas are more vulnerable than others in the Marble Canyon area. The red features highlight the very low flood risk. Orange highlights the low flood risk. Yellow highlights medium flood risk. Green highlights the high flood risk, and blue highlights the very high flood risk. The first map is the result of the multi-criteria analysis with the data from 2010 rainfall and 2017 land cover. The second map is the result of the multi-criteria analysis with the data from 2020 rainfall and 2020 land cover. And these are the results for the area around Marble Canyon. Based on the flood risk maps from Marble Canyon, the very high flood risk areas are southwest of Marble Canyon. The area around the cities of Page and Bitter Springs shows more medium flood risk on the 2020 map than the 2017 map. The direction of flow is going southeast. The weighted overlay maps for the Marble Canyon area show more medium flood risk between 2010 and 2020 the median flood risk has increased in some areas. The flood risk analysis map for 2020 shows that the median flood risk area takes up over 60% of the total area around Marble Canyon. The 2020 flood risk analysis shows that the median flood risk area is increased by 1%, with a difference of 139.42 square kilometers from 2010. The rest of the area shows a 14% high flood risk and a 0.5 very high flood risk in 2010, and a 1% very high flood risk area increased by 1%, with a difference of 139. Sorry, excuse me. Let me go back. The rest of the area shows a 14% high flood risk and a 0.5% very high flood risk in 2010, and a 1% very high flood risk in 2020. Between these 2 years, the values for very high and high flood risk also increase in the area southeast of Marble Canyon. The high flood risk area increased by 34.98 square kilometers, and the very high flood risk area increased by 4 square kilometers. Here are the results for the area around Winslow, Arizona. This first map is a result of the multi-criteria analysis with the data from 2010 rainfall and 2017 land cover. The second map is the result of the multi-criteria analysis with the data from 2020 rainfall and 2020 land cover. The flood risk map for Winslow shows the very high flood risk areas northwest of the city near Jadito and Kings Canyon. These areas show medium and high flood risk. The flow direction of the area around Winslow is going southwest. The flow direction of the area around Jadito and Kings Canyon go northwest. Looking at the flood risk map, there is a small area near Leah Corner that is high risk and could affect the city of Winslow. The weighted overlay maps for the Winslow area show more low flood risk. Between 2010 and 2020, the median flood risk has increased in some areas. The flood risk analysis map for 2020 shows that the low flood risk area takes up 40% of the total area around Winslow, Arizona. The rest of the area around the city of Winslow shows a 12% high flood risk and a 0% very high flood risk in both the 2010 and 2020 flood risk analysis, with an increase of 1.3 square kilometers. Between the years 2010 and 2020, the value increased in the area northeast of Winslow by the towns Jadito and Kings Canyon. The high flood risk and very high flood risk areas are increasing over time. Between 2010 and 2020, there is a 127.91 square kilometer increase in the median flood risk area and a 19.24 square kilometer increase in area for the high flood risk area. To sum up this project, the 2 areas of interest on the Navajo Nation are becoming drier as the years pass. The Navajo Nation has experienced a drought crisis due to climate change during the months of heavy rain and when the snow melts after winter. The excessive amounts of water doesn't absorb fast enough through the soil, resulting in flood disasters. The goal of this project was to identify and determine areas where flooding occurred near Marble Canyon and the city of Winslow. To determine the change in land cover from 2010 and 2020, to determine the populations affected by flooding, and to determine ways mitigating flood damages and risk in areas of vulnerability. To achieve these goals, flood susceptibility analysis was performed using ArcGIS Pro. The following factors were included in the flood analysis: slope, hydrology, rainfall, and land cover. The reclassify and weighted overlay analysis tools were used in ArcGIS Pro for each factor of the flood analysis. A flood risk map of each of the 2 areas of study showed the severity of flood risk. Allocated values were assigned to each flood risk area with the following labels: very low, low, medium, high, and very high flood risk. The results of the flood susceptibility analysis showed that the 2 areas of study are not in a constant flood crisis. However, it showed that the risk value is increasing as the years pass by. Before doing the analysis, I was only focused on Marble Canyon and Winslow. After analyzing the different factors of the flood susceptibility analysis, I looked at the surrounding area and found that there are other areas that could be affected by flooding. These cities are small towns, and the developers need to examine and understand the hydrology network, the rainfall data, and the flood risk data to determine ways to mitigate potential flood hazards and events. Completing this project motivates me to understand more of the geology, climate, and hydrology of the Navajo Nation. The people living on the Navajo Nation are limited to a lot of resources when it comes to natural disasters. Analyzing and assessing areas all over the Navajo Nation that are susceptible to flooding could help mitigate and prepare for flood events that could lead to damages and loss of life. And that is the end of my presentation.